I don't have time for art. You know what I mean? I have to codify as much of art as I can. I think a really important thing I'll maybe say to, I sense that you don't love that answer, but a big question is how much can I expect the developer to know? And what is the limit of that? And so I think like we're definitely saying like, hey, we don't want you to be developer artist. We want you to be developer who raises their hand and says, I'm not sure, so that we can come in and supplement your knowledge. Right. And we also want to know where that cutoff is so that when we think about where do we target our services that security engineers get involved, like we know when that is and we know what the volume is and we know how to do that. And like today, it's simple. It's risk assessment. They do a risk assessment, low, medium, high. We get involved for high. They're in it for low. There's not much art from low, medium, high, and that's actually important because there's a key assumption, which is that the design you came up with probably doesn't need to be fundamentally changed. Because if there's one thing is stride-based threat modeling will never coax you to change your design. It will simply tell you like, hey, mitigate these risks here.
Welcome to the Elephant in AppSec, the podcast to explore, challenge, and boldly face the AppSec elephants in the room. I'm Alexandra, your host, joined by my amazing co-host Tristan, a former security engineer and co-founder of Escape. Today, we're excited to have an amazing guest, Jacob Salassi, join us. Jacob is the Director of Product Security and Regulatory Expansion at Snowflake, where he has played a pivotal role in guiding the company through its pre- and post-IPO phases. With over 15 years of experience, initially in software engineering before transitioning to security, Jacob is a sought-after speaker at numerous conferences and podcasts, sharing his wealth of insights with others. Jacob has a deep passion for cycling, and he revealed to us that he does have a large repository of ideas stored in his smartphone notes that he records while cycling. Jacob held a strong opinion that product security should be approached as a science, not an art. Therefore, we challenged him on how, in this case, one can nurture developer creativity to build secure applications, and asked in depth about his scientific approach. Today is also a special episode since I'll be joined by another co-host, Antoine Carosio, CTO of Escape, instead of Tristan. So dive right in. Hi Jacob, we're very excited to have you today on the Elephant in AppSec podcast. Thanks a lot for taking the time and sharing your wealth of product security knowledge with us. And I'm very excited to approach it, from a scientific perspective and data-oriented perspective, because that's something I can personally relate to, and that approach is something I like a lot. And when I've been studying a little bit about your background, I came across your website. I think you posted on GitHub, yes, and then in your description, you are very straight to the point and direct. I solve problems. And while a lot of people, they talk about, okay, I'm VP product security or somehow related to their job. And I think I had a question that immediately, popped up, why did you decide to put this statement, first and be so direct?
Yeah. Thanks for inviting me. Happy to talk to you all today. Because I think problem solving, to me, I don't want to say it doesn't matter what problem I work on, but the problem is what gets me excited. And I find that there are certain areas where there are more interesting or more challenging for certain reasons, problems where they exist. And sort of throughout my career, two areas of that I've really enjoyed have been network engineering and security. And I think sort of if you try to look at it empirically, it's just because these are nodes with a lot of intersections. And there are a lot of technologies that come into play, whether you're doing network load balancing, where I spent a lot of my life, or whether you're doing security. And that means there's lots of problems and there's lots of different ways to observe them. And so I just like to solve problems. And I think it served me well later in my career when it was management and people problems. I like to get hyped about a problem and then try to solve it. And so I don't know that I bring another skill except an appetite to solve problems and then an appetite to learn what's required to do that.
Okay, technical or people problems, which ones do you like more? Which one challenge you more?
Oh, well, people problems is much more challenging because it's I'm probably using the term wrong, but NP hard, whatever, it can't be solved. It's unsolvable. You can try very hard to engineer your way out of people problems, but that's not a good abstraction. I think it's good to have structure, but the people thing is different, requires a different approach, and actually different strategies succeed. So I would say it's in some ways much harder to take an engineering approach to managing a team and cultivating people growth.
And how this like problem solving mindset, aligned with the security work that you're doing?
So in this case, security is sort of like a perennial problem. No one seems to solve it. So maybe it's like ego. It's like,
okay.
the hardest problem of all. Like I started in healthcare security, so the most dangerous game, right? But I don't know, like maybe it's some of that, but I just think it's not solved. That's pretty clear, right? So it must be something there in terms of problem solving opportunity in the security space.
Yeah. I think a lot of opportunities in a lot of different fields. And I think now, especially like within the recent years, there are even more things popping up like LLM, AI, and it just amounts more and more, each on top of the other.
We say this at Snowflake often, which is like we never stop inventing more dangerous stuff. So
so it's your fault, kind of.
Yeah, we just have to keep figuring it out, that's all.
I was wondering, talking about culture and people, you've been at Snowflake for a long time now, 5 years. So we said that earlier. You've seen Snowflake evolve from a mid-sized company to a public company. And we know that in your security team, in the product security team, you're making different teams working together. So you have software engineering teams, security teams, incident response, and threat detection. So what has changed from a product security perspective over time, and how do those people collaborate together? How do you create this culture?
So I think, of course, lots of things that changed at Snowflake, but I'll maybe talk about this part of the journey, which is as a security team, we first started as one single team. And this was pre-IPO. And what the business needed to do, one of the many things that needed to happen was we had to get sort of a corporate apparatus. That means IT and all these other functions, right? It's not to say we didn't have IT, not what I mean, but it means those functions had to scale. But Snowflake is a product company, and so we were a product-focused team. And what we found was our ability to influence IT diminished as the company grew because we were a product team, and like you naturally start to experience dynamics, and it's like, well, who are you? You want to be part. Turns out in security, I'm maybe like unburying the lead here, but like it turns out in security, it's better to appear as one of the group you're trying to influence rather than an outsider who's trying to drive influence. And there are many ways to achieve that, but that's a big part of what we figured out, and a big part of what our journey then sort of transformed into was we said, it's hard to do that. So let's think about a security structure. Like, how would we restructure our team? Turns out no one's going to solve that problem but you. So we got together and we said, well, how should we do this, right? What does it look like? So we said, maybe we can have three. We can have a global security organization, a parent. We can have a corporate security organization and a product security organization, children. And I use that metaphor for a couple of reasons. One, because it sort of implies at least some loose coordination. And then two, it also implies self-determinism, agency, and autonomy, which was important because what the product needs is not necessarily the same thing as what the corporate machinery needs. And it was important that product gets done what it needs to get done, but everybody gets it done safely and nobody dies, right? Like that's really the ultimate goal of parenting.
That's the goal.
In some sense. One of the goals, base case, But anyway, so we achieved that structure, and I stayed with the product. Mario Duarte, who's still at the company, became the VP of security. Snowflake at that time didn't have a CISO. And then we hired a peer of mine, Jifun Satape, who came to lead the corporate security organization. And that took a little bit of time, but that was the structure that eventually formed. And so then what we said was, I'll maybe answer the last bit of this, is now how do these teams work together? So we grew from like Somater and I, like two people just doing all of the reviews. We scaled a product, we hired people to start scaling and doing some of those things. And then we broke into these three orgs, but we still were kind of doing threat detection and incident response as a outside service. We had this global security team, but the integration into product wasn't great. That's not to demean any of the work that my great peers have done, but like it was what I would describe as a fundamentally transactional interface. It's like Jira's and conversations. And it actually relied a lot upon my relationship with Michele Freschi, which transcends this job and many other jobs, but like not a durable bond. Like he and I made a lot of things work because I could just call him up and we know each other, but there were teams underneath us. And we wanted to figure out like, how do you do this better? And so what we said was, well, we're trying to implement the entire stack in each area, right? The whole stack of security in product, the whole stack of security in corp. And especially, not especially, but my bias is toward product. It's like the risks and the stakes are high. And something that a lot of teams are good at out of the box is understanding corporate assets and corporate security, because they appear over and over and over. You will have worked with Jamf before. You will have worked with laptops before, but you may not have worked with a Snowflake before, and Snowflake today is not the same as Snowflake tomorrow. So the cost to like comprehend the system to a level where you can like write meaningful detections that are not just basic cloud detections like Open S3 bucket. Everyone can do that. What about some of the specific dynamics about how Snowflake works? These were the things we didn't see getting addressed. And we said, well, we have to like treat this as more of a first-class citizen. So we just arranged a dotted line relationship and said, I guess by this time we had established a notion of architects. So I have architects, and we sort of said, great, you can loosely model these as controls architects, risk architects, people who decompose the risk and propose the controls. Now I need monitoring controls. Now I need response. And so then you can sort of imagine I'm going to take architecture, detection, incident response, and offensive security. I'm going to put them all in a room, and I'm going to say, like, operate as a vertical, solve it, right? All the way. And it sounds simple. It works pretty well. But it was about elevating the IR and the TD presence to be one. You have to go to my peers. I say, you're going to give me a senior full-time body. They're going to sit in my staff. They're going to attend my meetings. They're going to report to you. You're going to do their performance reviews, but they're going to spend 100% of their time thinking about the product. It's important because you can say, well, I have people who are working for you, but if they don't invest enough time to become strategically invested, then you don't ever get anywhere, right? You just churn more tickets faster, but you don't gain any depth. That's something that's really important to us. So now our big focus, now it's all integrated, all good. We now have multiple resources in those positions so that you essentially have someone who can deal with day to day, and you have someone whose job it is to just think about 2 years into the future. And I'll close by saying, like, this is now for us that the main thing is to like fully integrate. We said we would dissolve security and AppSec into engineering, but like we're dissolving AppSec, TD, IR, and offensive security into engineering, because we can ask, what does a developer need to think about for each of these areas for every single change? And like, it's because we own that whole bucket that we feel like we should ask that question. I think that's something that's very unique about Snowflake, is like, we're not leaving TD and IR out there in the woods or whatever. You know what I mean? Like, we bring them right up to the change and say, do we need to ask anything here? On a per change level, often the answer is no. But on a per feature level and on a per strategic feature level, the answer is almost 100% yes.
I think very interesting approach to that. And I think you talk a lot about like how you structure it, about how people involved it. But when I think right now with the awareness of the Snowflake, immediately when you hear the name, especially like post-IPO, you think, okay, Snowflake equals data. So
right.
It any of those steps when you actually were structuring and thinking about like how to set up processes within those teams, did you leverage actually data at any of these points?
For sure. So almost from the beginning, because one of the things I carried with me from my prior role was this like salty opinion that threat modeling value is being wasted. Like, you just go and draw it on a whiteboard and erase it, or you go and talk in a meeting and you forget it and no one writes it down, and it's very abstract, has no definition. I sort of got this thing in my head where people would say, like, what's your threat model? And I would say, like, what does that even mean? Like, let me just go Google threat models and let me just see if even 2 of them look similar, or if there's even a single consistent definition. Even when you would read the books that are like, hey, do stride, it's like, how do you write that? I think this goes back to something I mentioned to you earlier, so I don't want to go back to the part we didn't record, but where a lot of the stuff I had read, it was like ideas, but no execution. So like, so then what do you do with this? How do you write it? And what does a developer do with it? Like, these were the main questions.
Like with voice memos that you are doing when you're riding a bike.
Right. So what I said was not what I said. It was serendipitous. I attended, you probably know Ken Johnson because he does Absolute AppSec, Ken Johnson and Seth Law. Yeah. So maybe not before, I probably heard about it at the same time. They used to do these AppSec training classes. It was a long time back. So I randomly attend one of these, and it was great because what they showed was this assessment template. And it was like, hey, here's how you can assess a web app, and here's the steps that you should do it. And like, in hindsight, it's super obvious, but like, hey, a template to do assessments makes a lot of sense. And so we first kind of glommed on to like, hey, you should have template to do it. And we thought the second thing was these artifacts keep getting thrown away. What is the thing that lives forever? Oh, it's the code. Like, how do we, as like brutish children, approximate this? We're like, we'll check Markdown in to a repo next to the code. And like, that was our infantile first thing. It wasn't yet about the data. I'm not going to lie to you. What we knew was like, hey, cool, we have this massive database we can store a bunch of Markdown in, which obviously that's not structured data yet. But we knew a couple of things. You could parse Markdown later, and that these TD and IR teams were like foaming at the mouth about the data they had in this database. And we were like, I don't get it. We're just AppSec people. And so I'll tell you, like, AppSec people don't get data. And we didn't get data 5 years ago, but we were at a data company. And we thought, well, right, we thought, well, this thing is not repeatable enough. It's not structured enough. And you start to see it as an unstructured to structured problem, which becomes a data problem. Once you can define a structure, you can then begin to iterate it, right? So very beginning, Markdown in the repos. And that was because we wanted developers to get involved, because we have a very developer-centric thing. So we wanted to say, hey, you can't be asking developers to do art each time, right? They got to be able to do the same thing. And in fact, if two different developers do it on the same system, it has to give the same output. Now, it's not 100%, but much better than, like two rando conversations about it. So that was our main goal. And we started storing it. And what we also encountered near that time was this rapid threat model prototyping process. Did not invent it. This guy named Jeffrey Hill invented it, or I don't know if he invented it or not, but it is like a way to reimagine trust boundaries. On a lot of data flow diagrams, which is something you're frequently going to see in threat modeling, you'll see these like red dotted boxes, right? And it's generally trying to show something that is trusted versus untrusted. So like the differentiation there would be crudely edge versus open internet, right? Anyway, he kind of took it a little bit further and said, well, you can sort of reimagine like anywhere the box touches, or first imagine, okay, a different one. Each of the nodes can have a box, let's put it that way, and you can convert that box to a score. And so the whole point of a trust boundary is so that you can do a relative comparison. Something is untrusted versus something is trusted. That is a base signal that like security may need to happen here, right? Like we don't know which kind of security yet, but like some kind of security. And now this leads you to the base problem with most threat modeling, which is it's like, hey, stride, spoofing, tampering. Folks can Google that. It's obnoxious because it is like a search space maximization. So you start with the maximum search space and then you try to eliminate. But like if you're a developer, that sucks because you're using all of these strange terms you don't know and you've generated a bunch of them. And now you have to try to get rid of them. So what was changed by RTMP was it gave you kind of 6 rules. It's like, hey, if you score things that are on the internet as 0, and if you score things where data lands as 9, and if you score things in between, there's a spider walking down my monitor, so hopefully this will be cool. If you score things in between as kind of like 2 through 8, you can get a more granular comparison. And if you actually look at the way the data flows, you can just start to say, hey, which stride things are interesting? So let me give you an example. If data is flowing from 0, in other words, the internet to the edge, I don't really care about information disclosure because none of my data is leaving. You know what I mean? But I probably care a lot about denial of service, and depending on the process, which for most people, when you draw a web app, it's like off. I care about spoofing. Sweet. So like if I just knew that it was going directionally from low 0 to high 1, I could eliminate a set of things. It's a first pass filtering mechanism. You can think of it that way. And then you can sort of do the same thing as if I go from high to low, then I do need to think about information disclosure. So this solves that first problem, which is it is no longer a max search space, it's a min search space. It also solves the second problem, which is no matter how you run it, the rules are always the same. So if you draw the diagram correctly, it will always produce the same set of threats. So now you've solved the second problem, which is when 2 developers do it, does it produce the same output? It also biases toward, like, what does developer know best? Of course, all models are imperfect, but developer knows best their system. So, like, probably they draw the diagram accurately 99% of the time, but they probably definitely don't do the stride thing right 100% of the time. So you're inverting it now. It's like I'm leveraging the thing you know best to show you a 80% suggestion of what you know least. That's like fundamentally the property we saw that this particular implementation gave us. Pretty good. And at that point, we realized you could convert that to SQL. And you could, instead of having developers, for example, carry out a high toil process of modeling this on a markdown document where we would literally have them draw the data flow diagram, link it in, and then they would walk through the steps and they would literally write, like we had cute little emojis and the whole thing, all the threats and so on and so forth. But we thought hey, wouldn't it be cool if we just looked at the graph and appeared the threats? Because basically you can generate 80% of the boilerplate text. You say, because data flowed from low to high, you have these threats. So this is where Gherkin came in. I don't know if you're familiar with this, but it's just like a structured English language. So now you're seeing we're slowly fumbling our way toward even more parsable data, which is we figured out one, if you store this as a graph, for example, you can literally query these nodes and edges, and one question you can answer is, do I have stride-based threats? So that's when the light bulb went off. We're like, oh, it is a data problem. What we're storing here is a property graph. And we're crudely storing it in a relational database today. And one property we store on it is this idea of which trust boundary you're a part of. But other properties we might store are, for example, the actual risk assessment data, some things about the feature, and the overall interconnectedness rather of the larger system. This is another realization we had, which was hey, each day for free, developers are giving us a graph representation of the system they think they are building. So we definitely glommed onto that. We're okay, we need to make it. First, we figured out hey, let's have them stop taking screenshots of the thing we have them do in Draw.io, and let's start parsing the XML, and let's start creating an intermediate representation of that data and storing it in Snowflake. That eventually led us to build our own UI on top of that and to just get rid of Draw.io so that we controlled the entire graph experience, which then meant we can do things, improve the UI, suggest things better. We can canonicalize the names of entities. At that point now, it is a data problem. And you're now thinking about, how do I do data normalization? Because I have 2 years of data where we weren't normalizing and we weren't this smart, but good thing we were smart enough to make it markdown so that we could parse all of it. And good thing we were smart enough to make it Gherkin so that you could parse all of that with libraries off the shelf. And we took the old data and cleaned it, migrated to the new inputs. And now everything is kind of just JSON. We have a JSON data structure that gets dropped into Snowflake. Every developer, every feature, they're generating this graph-based data for us. They're then going through a threat modeling process that comprehends how much risk you have, how many requirements you're meeting, what is the residual risk. This is now the other thing, where it's this graph is not just data about stride-based threats. Boring. You solve those. It has a massive property of exposing residual risk. It is now a sort of an expected state representation, and it is an expected state representation that contains a ton of metadata about risk. And so I can, as a security team, go back and just ask a question where is risk in my system? Where was it risky initially? Where did the risk get mitigated? Where was it not mitigated? There are now many, many, many questions that you can answer, and we haven't thought of them all, and we can't answer all of them right now, but this is what we figured out, and there are certainly a set of questions we do answer with it.
And what's the frequency, of you actually going and asking those questions?
So every change is at least getting the question of what is the stride-based threat for this. But for example, something that we've recently pivoted this to, which is it's industry leading, because I know. Anyway, we have abuse. Snowflake is a marketplace, and stride-based threats are. I can give you a whole treatise about how much I dislike Stride. All these years and all this way, I would say it's throw it away, burn it down. No, I'll have a lot of ideas about that. But anyways, what we thought was Stride doesn't help you model abuse. Boo, But we have all this data. How can we use the data that we have to model abuse? So then we started to think about how can we invented our own set of threats. It's hey, compute abuse, hey, crypto miners, hey, so on and so forth. And then we imagined this property graph and we said, like, what would we have to know to do to figure out where compute abuse might be? And so you might say, well, anywhere a 0, something on the edge causes an action that triggers compute use is an opportunity, right? And you can start to imagine, I'm not going to list the whole thing here because when I don't have the paper in front of me anymore, but like we went through this exercise and sort of enumerated, like, here are 4 cases. And can we did this experiment, right? Which was, can we then go back over the entirety of the data and surface all of the latent abuse cases that we may have missed, or candidates? Let's say candidates, because they need to be qualified. And how can we then apply those forward looking, right? Like once you can surface candidates, then you now have a query which can be executed at any time against any spectrum of data to ask this question. So it is every day in the base case of stride, and soon to be every day in the base case of abuse. Now, in this big meta thing of like, how often do we load up the entire graph and say, hey, how do you get from A to B? There's still challenges with that because we're storing this as snapshots, which lends itself to the 2 analysis I just told you. It's really great to look at a snapshot and run that. But coalescing all snapshots and, for example, asking like, what are all of the paths from A to B, which is an interesting question. It's like, it's hard. And then 2, we're not so motivated yet to solve that problem because it's like, well, the number of times I need to know that is actually not that high. Because if I, for example, want to know the current state of the system, I can always inaccurately sample latest, right? Like if I go to the end of snapshots, I'm getting latest. What I'm losing is the benefit of coalescing all past snapshots and then deduplicating them into a supermodel, but or meta model, whatever you want to call it. Anyway, it's kind of neither here nor there. Like these are things we have to grow into. What we're a little bit more interested now is in like, hey, how do we make it better for developers still? How do we, Gherkin is awkward, Stride is awkward. I'm going to cringe. How can we use LLMs to make that part better? Like, to me, that's just a very...
AI, LLMs?
To me, this is actually a great case for this. So it's like, yes, actually do this, but it's not, that's not all the magic, right? Like, it's the rest of this thing that I think is important. But there's certainly a big opportunity now it's an awkward conversation that we guide developers through now. Like, so we can make it even less awkward. And maybe we could even, like, something that... in a little bit before this hype train, but like Snowflake bought Applica and then we said, hey, Doc AI, we want to read your docs and make them structured data. And then LLMs came. So I would say like, hey, it's the same thing. This is structured data from unstructured data. And if you can read a developer's design document and ask questions like, hey, what are the nodes and edges in there? Like maybe that's an interesting thing to look at as well. It's harder than you might think. And designed artifacts have varying levels of quality. But I think there's an obvious huge space there. And there's companies that are already sort of looking into this, which is like, hey, I'm going to read your JIRAs and your design docs, and I'm going to tell you about security risks, which I think is a great idea. You know what I mean?
Yeah. I mean, for me, it definitely seems hard. I don't know, for you, Antoine, what you think.
It is hard. It is hard. Of course, it's a complex topic. And by the way, you talk about how you materialize threats and so on, and I saw that you developed an open source project that is called Materialize Threats. And at Escape, we love open source. So I was wondering, so here you're providing an innovative approach, at least to analyze data flows using diagrams and SQL to identify security threats. What's the story behind this development, and how does it fit in your current processes at Snowflake? Do you use it currently?
We definitely use it. I think probably we're maybe not the best open source steward in the sense that it's in our, there's a private fork that we maintain that gets actively developed. And it's also, so the biggest disappointment that I have, and we will rectify it soon as we migrate to Backstage, but we built the UX on top of copyrighted Snowflake code. And there was, without boring everybody here, like there just was not a strong appetite to open source that piece of the code. And so we were bummed, but we thought, well, live to die another day or live to fight, whatever it is. But then eventually we said, look, actually it might be better to move to something like Backstage anyway, because it's less custom and it's more geared toward the use case we have of extending the platform and so on and so forth. So that part is maybe mostly done. Like internal prototype is out there. This is one of these things that moves at a glacial pace because the motive is low. So I would like to come to you saying like, oh, we're the best open source steward ever and it's all out there. We're not. But we did make a
One
tech
day,
choice
maybe.
change internally to try to get here. So no one will say we are not trying, but it's taking a while.
Maybe in the next month, you come with a surprise for the community.
I'm hoping if I were totally transparent, what I would really like to do, and maybe it's slightly Snowflake selfish, but a lot of this functionality we can encapsulate as a native app. Snowflake has an idea of application marketplace. And so like for a set of customers, if we could teach them how to do the ingestion, like to me, that's actually better. I rather model this. Materialize threats does too much, as a matter of fact. It's a data ingestion problem. You need to, one, have the input side solved so that developer is giving you the normalized input so that you can do ingestion. And I think like that's where folks could take materialize threats today and do what we did. But you quickly realize that like, hey, to scale this, no one wants to use Draw.io. Like I'm going to have to wire my own front end into it. And then I'm going to say like, oh, my data model has these things that I really care about and lots of other investments. I think we'll be really excited when we port everything to Backstage, because there's a lot of functionality that I described to you in terms of like, hey, I've looked at your I understood who you are, what team you're on, what technologies you're using, like GoSDL, if you remember that. Like we never abandoned that. We just kept extending it. And so we understand everything about you, and then we can figure out whether or not you need to threat model. And if it's not, that's when we're doing this thing of like, hey, I'm going to curate you the set of requirements that I know are here. So if you're on our database security team and you're implementing a permission, like we know all about that. And that's a high risk activity, but we have all of the things you need to do to make that a low risk activity. And something else is just this idea that things don't become low risk. They're always high risk, but they become mitigated. And so then by storing all of these properties to kind of roll it back again, it's like, it's very powerful to understand where you think you've mitigated risk, where you're making an assumption that risk is mitigated, and maybe you want to check on that, or to find out the places where you're calling it low risk and you're probably not checking as much, right? Like having a quantified search space, period. And this is just for the developer-driven part. Like we have an entirely different approach that generates a very similar set of properties when we put a security architect on a project and we own the risk decomposition. But being able to say, I have a search space. I understood how the search space was established. I understood my coverage of the space, and I understand the things which are not targeted by my space. It's not just data, which is a big part of that. You can always represent these things as data, but it's about an engineering approach where we're trying to structure and repeat things. Because I just felt the fallacy in the industry was, we're a bunch of artists. You know, it's not that helpful for engineers.
Why?
Because engineers on a day-to-day basis operate in a world that they think about repeatability, and the same input yields the same output. I think actually that's really important, and it's an important property of a system. And art doesn't guarantee anything except that someone might appreciate beauty. Like my stakes are much higher than someone should do it, right? Like I have to guarantee security. Therefore, I don't have time for art. You know what I mean? I have to codify as much of art as I can. And I have to, I think a really important thing I'll maybe say to, I sense that you don't love that answer, but a big question is, how much can I expect the developer to know? And what is the limit of that? And so I think like, we're definitely saying like, hey, we don't want you to be developer artist. We want you to be developer who raises their hand and says, I'm not sure, so that we can come in and supplement your knowledge. Right. But we also want to know where that cutoff is so that when we think about where do we target our services that security engineers get involved, like we know when that is, and we know what the volume is, and we know how to do that. And like today, it's simple. It's risk assessment. They do a risk assessment, low, medium, high. We get involved for high. They're in it for low. There's not much art from low, medium, high, and that's actually important because there's a key assumption, which is that the design you came up with probably doesn't need to be fundamentally changed. Because if there's one thing is stride-based threat modeling will never coax you to change your design. It will simply tell you like, hey, mitigate these risks here. Well, what if the whole design is a bad idea? Actually, that's not the right way to find that out most of the time. So there are a lot of like baked in things that when you think about what you ask a developer to do, you actually need to be quite intentional because you can't ask someone to do things which is outside of their domain expertise with a high level of precision. These kinds of things.
And how, in this case, do you, for example, nurture, developers' creativity when it comes down to security? Let's say a developer wants to bring a new project, and because we discussed like security champions, and you have like security partners that I think the name came and you told me from Facebook. And but how do you actually nurture that part? Because some people have to also become creative. Maybe I'll come up with creative solutions.
Okay. I think it's a great way you've asked this question. So it does have this property, which is we're saying by doing this on Rails non-arc thing, you generate 80% of the problem space with 0 of the toil. Like in exchange for the diagram, I'm going to give you the answer. And then what I'm going to say is think about the remaining 20%, or maybe the remaining 1% and the existing 19% of error. You know what I mean? Like essentially it says like I've done most of the thinking for you, and now you're free to just spot the errors. That was our hypothesis. Like it actually does bias toward that. It says developer doesn't spend, if your mental energy is finite, right? We don't spend any of the mental energy on the toil. We only engage the critical thinking part. And we say critically think about the 80% of the problem we generated for you. We want you to optimize for 2 things. Did we miss anything? And is it incorrect? So that was the hypothesis. What I'll tell you in practice is the language of Stride and all of this stuff, like you can get the 80%. They will still struggle to do the last 20% because it just doesn't cleanly translate into mitigation design docs. Like you still have to do a lot of talking on that last part, we find. And in other cases, we find like, hey, actually, they may have misunderstood this. So actually, a big side effect of this approach is you have to do quality checking. Like we have to sample at a rate, and we have to review threat models. And like that is a non-zero amount of stuff that our on-call does to sort of stay on top of the quality thing, right? And this is where it sort of goes back to my earlier statement. It's like we would like to rethink how you can get your hands around the quality piece, because we pay a quality penalty by asking them to speak a slightly foreign language and use slightly foreign principles. And this sort of goes all the way back to what I said is like, it's about the design doc. Like that is where they are. We have this great setup that gets developers to do this extra step for us, and we're great stewards of it, and we make sure it's as good as possible. It's still not good enough because it like shaves off, or it has this tax on the output. It lowers the quality of the output. And so we're just thinking like, how do we get closer to that design doc in that code? Because all you're doing is generating a model of the system. You're materializing a model of the system, and then you're just doing little analyses on it, right? And you want to just reduce one, make it cheap to do, and then 2, increase the accuracy of that model. And the translation reduces the accuracy.
Yeah. All right. That was really interesting. I have one little personal question. I guess we live in a world that is full of inequalities because, there are companies that have a lot of data available, like Snowflakes, and there are companies like Escape that are small startups which has very low data available. So how do you think security teams should leverage that data depending on their state? And in those both cases, how should I handle that as a CTO of a small startup?
So what I would say is, if you're doing security review, and like we'll take that as a foregone conclusion, then you're already paying the tax, but you're retaining 0 of the value. So I would say to that person, you have the data, you're just throwing it away. So I would say you should capture it instead. Now, the thing is that look to the industry and there's crickets. No one is ready to make that happen. So now this is where it is unfair that I work at Snowflake and getting data is a trivial problem for me. And building a UX, I had engineers to get it done. I would say, think of Backstage as a data ingestion problem. The number one thing that I think is AppSec teams are just not data teams. And I don't necessarily mean that they need to be, but if everything is an ingestion problem, then everything is an ingestion problem. And as a matter of fact, if is there some way that I could get developers to use an experience that would generate some information? Could I put, to get data, you have to have a system, they have to use it, right? So like these teams then have to go and say, oh, we have to make that investment. Now, it doesn't mean you can't do AppSec without this. It just means like, hey, you're doing this point in time, and there's a lot of value generated out there right now to a point in time analysis, but it'll never be more than that. And so don't kid yourself. Until you're thinking about this end to end, in fact, even further to release in the cloud, which is where having the data really matters. I can think about what I thought I built and what I actually built. Like, that's a big deal. But yeah, I just think it's an investment teams have to make, but what a lot of teams don't realize is they're already generating the data. They're just not saving it. A lot of people will think, oh, I have to go do something new. It's like, no, you're doing it today. You just don't typically think about it this way.
According to you, whatever the stage of the company, you can leverage data the same way. The hard part is more to collect it, actually.
Yeah, I completely agree. And especially today, it is trivial to comprehend a document with a machine and ask questions. This whole problem space is about translation, costly translation of non-domain experts to domain experts, right? Like, you have developer domain expert, security non-domain expert. Problem number one, security wants to comprehend the design of the document. Okay, then you invert that and you say, now I'm asking developer to do security. Now it's developer non-domain expert crossing this chasm of translation. And like, it's a language problem in a lot of cases. It's like, hey, you're just not using language that makes sense to me, but like, it's not that these terms can't be mapped. So I do think there is a big opportunity for LLM in this case, or just NLP, let's call it that, and not specify what the implementation is. But like, that is a huge, and this shows up over and over and over. And this is why you see AI for lawyers, AI for healthcare. Why? Because some human has to read some text somewhere and create some intermediate representation and then tell some other human what that is. It's like, it's turtles all the way down.
Yeah, I mean, we had an episode actually of like Gen AI for AppSec, and the main part of the discussion was how to translate threat modeling doc, how the AI potentially can analyze, let's say, threat modeling documents and assist AppSec engineers. And I think you mentioned quite a lot of time, like, AppSec is not really like data oriented. So what would you recommend then young AppSec professionals to learn to succeed in their job?
I think the first thing they should look at is, what is the security data lake doing? What is security data doing for threat detection and incident response teams? I think that was very illuminating for me to just start thinking about security as a data problem in general. And like, maybe there's a lot of bias towards in Snowflake because of where we are, but like, everyone I think is aware of the security tool silo problem. Like, I go to tool A, and then I can only get some data A, and I got to go to B. And so then you got like Splunks of the world who are saying, hey, get it all over here. But Splunk is fundamentally like a search-driven approach. Like, it caters to someone who knows what they're looking for, and they can dig through the haystack, right? So then what we would argue is like, that's not great. Like, how about you model that data and store it in a database so that you can look at more things? So I think as a security team, if you're not thinking about a data-driven approach to TDIR, like a single data approach, probably in a relational database, maybe that's overly opinionated, but like, I don't think search is it. So I think teams should first start exploring, like, how could we do that, and how could we start experimenting with that, and what sort of use cases could we power? And they're probably often going to start with threat detection and incident response cases because it makes a lot of sense. And whether you're simply ingesting alerts from another tool or multiple tools and deduplicating them, like, this is probably ground zero for lots of people. It's like, hey, you don't necessarily have to go into those silos and get all the data out. Like, you can just take their insights, aggregate their insights, and then deduplicate their insights, which is often a frequent problem. Like, there are a lot of alerts and alert fatigue, and like, this is a key thing we focused on first at Snowflake, which is like, hey, just deduplicate alerts and raise the fidelity of what responders deal with. So there's that. And then I would just say, hey, AppSec teams, you're feeling this pain more than you think today. Like, think about how you can get control of the UX so that, in other words, how do you make this a curated experience so that you can begin capturing this data? So I think that's the other piece, which is a bit more forward-looking. But I think like going and understanding, and then what I feel that allows you to do is to understand the complete picture. Because I think here, our belief is that, like, by the way, this is still not good enough. Enterprise data already exists. It is security that is over here in silos, and security that thinks it has a security data lake, but actually you're just part of a larger enterprise data set. And for us, it's actually quite important to have the workday data proximate to our incident response data so that we know what laptop belongs to whom and if you're on PTO and whether or not you're leaving in 2 weeks. Like those things don't happen when you work in silos. So maybe that's not the most concise answer, but I just think I have to open your eyes and see what you're missing and then start making some investments.
I mean, I hope that the listeners of the podcast, I hope that for them it was an eye-opening answer. And I think that's one last question that we always ask, at the end of the podcast. And you also mentioned, before, that you love to learn new things. So what book or online resource book specifically, probably, would you recommend to actually speed up, and to increase your learning, increase your knowledge on security?
Well, I'm going to answer that anyway because it's like a very broad question. So I'm not going to suggest a book that has almost anything to do with what I described here. I'm going to talk about quantitative risk analysis, which is where I spend most of my time thinking about now. And like, how do I bring that to the fingers of every engineer? Like, I feel like I brought threat modeling to the fingers of every change for every developer, or we brought, the team and I brought. The second thing we wanted to do was, I told you, we think a lot about the limit. Like, so when I stop worrying about developers and I start worrying about security engineers, like, what is it that I care about there? And in that case, I care about bringing quantitative risk analysis to every single security engineer's job every single day. So to me, the most important books I've read on that are Managing and Measuring Information Risk, which is the book about FAIR, which is like the industry standard approach. I'm not going to tell you cargo cult FAIR and like it's magic. It ain't. The second book I'll tell you to read is one called Engineering Trustworthy Systems, which is based on a U.S. government approach to risk decomposition. And I'll tell you that the magic happens when you read both of the books, and then you think real hard about what do they do differently, and you smash them both together. And then what you can end up with is a very compelling story about how, from engineers' lips to the ears of the board of directors, which is more or less what we do today at Snowflake. And that has been sort of the latter part of my career, has been focused on like, how do I make that actually true so that the risk doesn't flow down, it flows up from the bottom where it actually comes from, and how do we make that structured and repeatable and search spaces, and how do we know, and how confident, and then how do we talk about it in a way that the board cares about. So those two books, I think, were the two things that made quantitative risk actionable for us, but there was still quite a bit of inventing and stuff we figured out since then.
Okay, so what's harder, board of directors or engineers? Who's harder to persuade when you launch new
engineers?
Wow.
Yes. I feel executives are not that hard. Like, in fact, executives really value not being surprised and being predictable. So in the same way that they don't want to be surprised and have unpredictable things happen, they're often unsurprising and predictable. And so I think it's about like the human piece. Like, you got to read the room, and then you got to be convicted, and you got to speak truth to power. Like, they don't pay us to come tell them nice things. They pay us to tell them what to worry about and to be credible about doing so. And for me, I just spent however much time we spent telling you, like, this is how I know I'm credible when I stand in front of a bunch of scary people like a board of directors or whoever else. Like, I need to feel like I know what I'm talking about. And sort of all of this is about that. So that's how I deal with it. We just show them the data. We talk about the facts, and it's there,
Okay, very interesting reply. It's not always actually the case from what I've heard.
It's not. No, we're very fortunate. And a lot of security people are going to be like, "Oh, curse you." And I know when Ken used to describe how good it was in the early days of GitHub, I would be like, "Man, I don't like hearing about how good it is for you." You know what I mean? But hey, it is what it is. I find myself at Snowflake, like, the stakes are high. We're trying to get all the government customers and everything else. Like, we just have to execute flawlessly on security, and you want to do that credibly, because I can't be wasting the company's money. You know what I mean? Like, we talk about a lot of fancy stuff, but it's like, how do I know just how fancy should it be? I think quantitative risk is a big part of how you begin to approach that. It's not magic, but it's engineering and science, which then allows you to be like, hey, how much does this cost us? How much risk might we mitigate, and how much is it going to cost us to build that? I don't think a lot of security teams even think about that.
Yeah, I don't know, because I think right now I'm started to explore that field, and I think there is still a long way to go, and lots of things to learn. And well, thank you so much, Jacob, for sharing with us your knowledge. It was super interesting and very insightful. So thanks again for being in the podcast.
Thank
Of
you very
course,
much.
thank you very much. And thank you.
Hope to see you in San Francisco.
Yeah, hey, if you guys are here, let me know.